So equality of complex numbers. So complex numbers are equal if their real parts are equal and if their imaginary parts are equal. So we can use this to solve some little equations like this. So x plus 1 on I plus y over 2 minus I is equal to 2 plus 4i. So what I'm going to do is I'm going to work on the left hand side first. I'm going to realise the denominators. So I'm going to multiply by the conjugates. That's going to give me x minus ix plus 2y plus iy. This one's going to be over a squared plus b squared, and 1 plus 1 is 2. This one's going to be over a squared plus b squared, and 4 plus 1 is 5. So left hand side is equal to this. Now what I'm going to do quickly is just get it over a common denominator. Common denominator will be 10. Multiply this one by 5, I have 5x minus 5ix. Multiply that one by 2 plus 4y plus 2iy all over 10. Now the question is saying that this is going to be equal to 2 plus 4i. So if I extract the real part here, the parts without the I, that's 5x plus 4y over 10 would be equal to the real part on this side, the 2. The imaginary part, negative 5x plus 2y over 10 will equal 4. And to find x and y, I have to solve these simultaneous equations. So we'll quickly go and do that. And we'll start by multiplying by that 10. So we get 5x plus 4y equals 20. And we get negative 5x plus 2y is equal to 40. Alright, they're nice and easy ones to solve, as you can see. Simply by adding them together, we'll end up with 6y equals 60. So y is 10, and subbing it back into anyone, we should get x is equal to negative 4. Okay, factorising a complex expression over c, so I'll start off with a nice easy one, something like z squared plus 49. So we can't factorise that over the real numbers, it's not a difference of squares. What I'll do instead is I'll use the fact that I squared is equal to negative 1, and then I'll be able to make a difference of squares. So I'll say z squared is equal to, z squared minus 49i squared. So this expression z squared plus 49 will be z squared minus 49i squared. I squared being negative 1 times negative makes a positive. Difference of squares, so I can simply factorise that now as z minus 7i and z plus 7i. So for two terms, that's nice and easy to do. If it's three terms, if it's z squared plus 2z plus 7, there'll be no factors of this over the real field, and so to get linear factors, I will complete the square first on the z squared plus 2z. So to do that, I have to halve the middle. So halving 2 is 1 and squaring it is 1. So that means this part here is z plus 1 all squared. Now I had z squared, had a plus 7 on the side here. I've just added 1, so I'll subtract 1 to counteract the one I added. So I'll get plus 6. Now again, this is almost a difference of squares. To make it so, I need to turn that into a negative. So I want z plus 1 all squared minus 6. But to keep it balanced, I squared. Negative times negative is positive. This becomes my first term, so it becomes z plus 1 minus. Now this will be root 6i when I factorise it. And this will be z plus 1 plus root 6i in factored form, just using a difference of squares factor on this.